Hello 108 students, Mr. McHugh here with you, back on section 7.3. Going to work on page 2, objective 2, and guess what? Method number 2. We got some rhythm going here. Well, okay, so method number 2, let's talk about this. We are now going to, for me, my big advice for you is to identify the rational expressions that you are dividing. And I'll just jump down here to example 2 to kind of set this up a little bit. And I want you to make some changes to your notes here. So here's the story. Look at this problem. Oops, they say, get it down here. Okay. 2 divided by 1 plus 1 over y, all divided by, and think of that big fraction bar again like the Berlin Wall. You've got the top half of the numerator and you've got the bottom half. Your first big task is to identify how many rational expressions you have. Now, when I first taught this and I made these notes, I made a big deal about this star and this plus sign. I want you to ignore all that. That's not how you're going to determine how many rational expressions. I thought it was, and it's not correct all the time. Okay, here's the deal. Look for the fraction bars. 1, 2. That is the key. So you have 2. As soon as you see 2 rational expressions in either the numerator or the denominator, you're going to use method number 2. I will explain what that is in a second. Come down here, look at the denominator, look at the rational expressions. How many do you have? 1 fraction bar, 2 fraction bars, so you are going to use method number 2. Okay, that's the way it always works for you. And the reason why you're not counting the pluses and minuses is if I had 2 plus y all over x, and I asked you, and pretend that's up in the numerator, and I asked you how many rational expressions do you have here. If you went and counted the plus signs as to figure it out, you'd be wrong. You have to count the fraction bars. So that is a single rational expression up there. Okay, minor details, but if you know how to do your reads, again, think of Kellen Moore, for the former quarterback for the, it hurts to say that, for the Broncos. That's what you're doing. Okay, now what are the steps to do this method number 2? Okay, the goal here is you're going to clear out the rational expressions in both the numerator and denominator by determining the LCD from both fractions. You're going to look at the denominators in the rational expressions that's in the numerator. Think of the top half and think of the bottom half. Okay, once you figure out that LCD, you're going to multiply across the top half and the bottom half, aka numerator, denominator, and you're going to clear out the rational expressions. Okay, and that's what the multiplying by the LCD is all about. Step 1A. Step 2, simplify the resulting fraction that you got there. Okay, so let's go here and try to take this example 2 and work our way through it. Okay, now we've already identified you got 2 rational expressions. You're going to use method number 2. You now need to determine the LCD. Now, I just have one little side note before we start here. The book, if you go through the book and you read it, you might be saying the book says you could use either method on any type of rational expressions you got here. It doesn't matter how many you got. Okay, I'm still sticking to my guns that if you see 1 rational expression in the numerator and the denominator, use method number 1. If you see 2 rational expressions, use method number 2. However, if you like method number 2 and you like the idea of clearing out the fractions by multiplying by the LCD, I would recommend you could always use method number 2 no matter what. Okay, now that choice is up to you, but I would not use method number 1 on this type of problem. If you don't believe me, go find examples in the book, study those things, and see the complexity, and shake your head and say, why in God's name would you do that? Okay, so let's go back to the problem here. Look at the denominators. You need to figure out the LCD. Each denominator is a factor in the LCD. 1 and a y. Okay, down here in this guy. Now what I did was, this problem might have been just the whole number 2. I put it over 1 to help you see what the denominators are. So you get 1 and a y, therefore the factors of each of the denominators have got to be in the LCD. This one's pretty easy to see. You're left with a y. Okay, so you know that is the LCD. Your goal is to take the whole entire top half, or the 2 REs in the numerator, multiply by the LCD. Okay, now if you want to put y over 1 to help you see it, that's cool. Same thing down here. Okay, now what you're doing now, and is you got a choice. I just used the distributive property here, and I mentally did my work. Sometimes I've seen students squeeze, and I'll do this, sometimes I'll squeeze the LCD next to each of the rational expressions so I could do this clearing out of the fractions. Whatever way works for you, so we'll just stick with what I did here. I basically took 2 times y and produced 2y, 1 times y and produced, what did I produce? Plus 1, y. How come? Because y divided by y equals 1. Go down here and do the bottom half. Multiply by the LCD, which is y. 3 times y, or y times 3 is 3y, so you're going from here down to here. 2 divided by y times y, the y's cancel out because they're divided by, anything divided by itself equals 1, resulting in minus 2. Okay, and once you've done that, you look at it. Now this one we're stopping. Why? Because if I try to factor out something, I can't pull out a GCF, so you're simplified. Okay, so that's page 2, introduction to method number 2. Again, remember, you're looking for how many rational expressions are up in the top half, how many are in the bottom half. Look for the fraction bars. If you see 2 of them, use method number 2, and you're going to determine the LCD and multiply by it. Okay, Mr. McHugh checking off here. We finished page 2. When I see you next, we're going to go on to page 3 and trying to make decisions choosing between methods 1 and 2. So we'll get a chance to do a couple more problems here and get you comfortable with these complex rational expressions. Okay, Mr. McHugh signing off for now. I'll see you in the next video. Okay, bye-bye.